Robots aren't just learning from us anymore. They're moving so human it feels unsettling. And in one bold drop, LimX may have just redrawn where robotics ends and humanity begins. Meet CL3, the full-sized humanoid that punches a 9-to-5 shift and then glides into a yoga cooldown smoother than most of us manage after desk duty. 52 joints ripple in near-perfect harmony, turning brushed alloy and servo whir into something that looks alarmingly like flesh and sinew. But don't blink. Halfway through, we'll crack open the uncanny secret powering those two human motions, how LimX is teaching a machine to move by binging nothing but human video footage. If you thought the humanoid race already had a finish line, CL3 just kicked it over the horizon. Welcome back, guys. Alfie here, and you're watching AI Nexus, your weekly dose of mind-blowing robotics updates. Trust me, you aren't ready for this one. First, let's talk flexibility. Human-level flexibility in a robot. LimX Dynamics just dropped a stunning video featuring their CL3 humanoid stretching after a full day's work. And no, this isn't CGI or some flashy demo. This is the real deal. The video opens with CL3 clocking out after a standard 8-hour shift. But instead of shutting down, this 176-centimeter, 83-kilogram machine rolls its shoulders, folds its hands behind its back, and begins a slow, deliberate forward fold. Exactly the kind of movement a stiff office worker might do before heading home. We're talking 52 joints working in perfect harmony, giving CL3 a staggering 52 degrees of freedom. Imagine this. The robot bends down, twists at the waist, and even drops into a single-leg pistol squat without losing balance. The transitions are not just smooth, they're eerily precise, thanks to LimX's hollow actuator design and custom high-torque density motors. Each actuator delivers up to 350 Nm of torque, while weighing less than a liter bottle of water. That's the kind of power Olympic weightlifters generate, packed into a device the size of your forearm. But here's an intriguing thought. Could robots soon outperform us in tasks that demand flexibility and stability? These movements aren't just impressive, they're practical. This range of motion means robots can slip under conveyor belts, reach awkward shelves, or kneel beside hospital beds, places where rigid industrial arms simply can't go. Forget stiff, clunky automata. CL3 moves almost as fluidly as you do. Ever wondered how machines pull that off? The secret lies in a synergy of hardware and software. Those hollow actuators we mentioned earlier double as structural members, hiding cables and cooling channels inside the drive itself. This keeps limbs slim while lowering inertia. Add in closed-loop torque control running at 2 kHz, and CL3 can sense and correct micro-wobbles faster than human reflexes. But LimX isn't satisfied with mechanical wizardry alone. They're pushing the envelope further with an AI pipeline called Video Gen Motion, VGM for short. Brace yourself, because this next part flips conventional robotics on its head. With VGM, LimX feeds ordinary human videos into an embodied learning stack. No LiDAR scans, no motion capture suits, just raw footage scraped from phones and CCTV. The system then reconstructs 3D skeletal trajectories, fuses depth via a generative vision backbone, and outputs a robot-specific motion plan. What happens when a robot can learn a task by binging YouTube the way you binge Netflix? Picture a chef posting a cooking tutorial at night, and by morning, your robotic coworker already replicates that Julia Child wrist flick to flip an omelet. LimX breaks the workflow into 3 phases: training, reasoning, and execution. During training, the AI fine-tunes against a small, curated set of manipulation clips. In reasoning, it uses text prompts, pick up mug, rotate 90 degrees, place on coaster, to synthesize brand new sequences. Finally, in execution, the plan streams to the robot's low-level controller at 240 Hz, adjusting for friction, slip, and sensor noise in real time. The wildest part? The pipeline requires zero robot-collected data. That annihilates one of embodied AI's biggest bottlenecks: expensive trial-and-error cycles that wear out hardware and burn through weeks of engineering time. LimX claims their data performance ROI is 10 times higher than the industry norm, cutting deployment costs by 65%. But here's where it gets crazier. Engineers have already demoed the same model, driving 3 dissimilar robotic arms, one with suction cups, one with 2-finger grippers, and one with a 3-jaw chuck, without retraining. That kind of cross-embodiment wizardry could standardize automation the way USB standardized peripherals. You might be asking, where does power come into play? Glad you asked. CL3's modular battery, 5.2 kWh of high-density lithium silicon cells, can hot swap in 90 seconds. Picture a pit stop crew sliding out a pack, clicking in a fresh one, and the robot marching back to work before you've refilled your coffee. And let's not forget brains. CL3 runs a custom-edge compute stack powered by NVIDIA Orin, giving it 275 TOPS of AI throughput locally. That means it can classify objects, run VSLAM, and handle natural language queries without cloud latency. Ask it, "Hey CL3, can you pass me the 14mm wrench?" And boom, it'll locate, grasp, and hand over the tool in under 3 seconds. What if your next project manager is a robot that never forgets deadlines and never needs coffee? Numbers are fun, but what's the real-world payoff? Automotive giants are eyeing CL3 for final assembly, where tasks change daily. Hospitals see potential in overnight restocking and patient lifting, slashing nurse back injuries. Even film studios want a stunt double version that can execute pre-visualized fight moves frame perfect, saving weeks of rehearsal. Let's zoom out for a second. Humanoid robots have been 5 years away for 20 years. Boston Dynamics danced, Tesla's Optimus waved, but none have cracked seamless human-environment interaction at speed. LimX's stretch video might look like a fun PR stunt, yet under the hood, it signals that full-body compliance control is graduating from research paper to product spec sheet. How do humans feel about metal colleagues limbering up next to them? Early field studies show workers interacting with CL3 report 27% less tech anxiety when the robot performs a familiar stretch routine. Copying human micro-rituals isn't just cute. It's a psychological bridge that makes adoption smoother. Okay, let's futurecast. Picture a distribution center in 2030. Half the staff clock in through biometric turnstiles, the other half roll off charging docks. Robots start with a morning stretch, check Slack for work orders, and pair up with human teammates in a hybrid Kanban workflow. When demand spikes, additional units get delivered by autonomous truck and sync with the warehouse mesh network in minutes. We can't dodge the tough stuff. Will these machines displace jobs? Short term, some, yes. Repetitive, injury-prone roles will shrink. Long-term, analysts at McKinsey project a net gain of 12 million jobs globally as new categories emerge. Robot health technician, ethics compliance officer, motion data curator. What if CL3 is only chapter 1? LimX's roadmap teases a CL4 prototype with variable stiffness artificial muscles and a projected top speed of 6 km/h1. Fast enough for campus deliveries and outdoor patrol. Combine that with VGM 2.0, adding language-conditioned manipulation, and we're inching toward robots that not only copy our stretches, but also understand our jokes. So what does all this add up to? Fewer repetitive strain injuries, faster throughput, and a labor force augmented rather than replaced. Think of CL3 as an exosuit you don't have to wear. One that can work the night shift, learn TikTok dances for morale, and still manage a Zen-level hamstring stretch before dawn. Could these built-in reflexes one day surpass our own and become an invisible safety net for human workers? And let's crunch some dollars. A fully loaded CL3 unit, including software license, service, and battery lease, runs $180,000 in year 1, dropping to $40,000 annually thereafter. Compare that to the total cost of 3-shift human coverage with overtime, roughly $190,000 a year in mature markets. Once the robot's paid off, the ROI compounds fast. But cost isn't the only metric. Consistency, uptime, and injury reduction drive intangible gains. Amazon once suggested every lost time accident costs $56,000 in direct and indirect expenses. If CL3 prevents just 4 injuries a year, it's effectively free. So here's the big question. Are we finally at the tipping point where robots become better coworkers than humans in specific roles? Drop your thoughts below. Do you welcome a limber, data-driven teammate, or does the idea still feel unsettling?